Let me just check whether I'm able to hear properly. Let me just check whether I'm able to. Great. Okay. What we're able to do is start recording, and it will automatically hear and record everything I'm saying. And then if I click stop recording, it will give me a waveform of what I've spoken, and I can control the waveform. So we are already here now, and let me open my Dialog Draw. Audio modifier we were doing. So what we were discussing was that we already have this event.data, and if you modify this event.data, we will get something. We can change the audio as well. So let me just see. Okay, this blob is the one that we have. Okay, size, and we have the type. The stream text. Just that's like the superclass of blob. Not needed right now. Okay, let's see. Modify audio using JavaScript. Now process the audio blob using the web audio API or the libraries. Okay. So what it's doing is it's reading through the blob, audio context, new audio context. Okay. Audio context dot decode audio data. We target on. Okay. What you want to do is actually change the audio's pitch. Okay. Pitch. Web audio API. Okay, let's read more about the web audio API. Web audio API. Okay. Let's go through this. It's like a powerful and versatile system for controlling audio on the web, allowing developers to choose audio so they add different create audio visualization, apply special effects, and much more. Handling audio waves and audio context and event. Um, Interchange and simple apps by their input and output. Typically start with one or more source. Or just recording the sound into the input or the other, which makes or modify the streams or sound samples into different streams upon one input effect destination. Create audio content inside open to create so such as oscillator stream. Create append such as reverb, by word filter, compressor to final destination of, for example, your system sphere. And this also up to the effect, and the effect is destination. Okay. Minimal sample frames inside the buffer and some. Yeah. Yes. Okay. Planar versus interleaved buffer. Is that what you're going to use a planar buffer? If I'm not recursion. Uses only planar buffer, reduces the format but converts the audio. Not record for playback. Conversely, when AP records an MP3, it starts with the interleaved. Um, these are the different channels: mono, stereo, left and right, quad, left, surround right. I've gotten my waveform. I can
Start
play.
recording. So I'm recording my audio one, two, three, and I'm going to stop.
Okay. And now play my
Start recording.
modifier.
So I'm recording my audio one, two, three, and I'm going to stop.
Okay. So in my ears, I'm able to hear it at a higher speed. If I reduce the speed, I will be able to do that. So audio, like let's look at the audio context object. So destination, speakers, mass context. I can account one number of inputs, number of outputs, context, speakers. Yeah, so we can expand the audio. Channel count 2, channel count mode explicit, channel interpretation speakers, context, max channel count 1, number of inputs and number of outputs. Context, we're able to increase the speed. Let's try reducing the speed 0.5. Oh, 9.5, 0.5. Okay, this is a test to see the actual speed of the audio. Hello, one, two, three. Stop recording and let's play modified audio. Wow, that's weird. Okay, I think we should definitely print out audio context order. First our destination, connect audio context or destination. It's just taking the speakers. Okay, so using audio, we are able to change the audio and play the audio. Remove background noise from the audio. That's interesting. First of all, I'm not able to hear that much audio. So, for example, I think I should disconnect my earphones. Let's see. Test to see how much noise there is.
Hello, this
This
is
is
a
the
test
test
to
to
see
see
how
how
much
much
background
background
noise
noise
there
there
is.
is.
Hello, this
This
is
is
a
the
test
test
to
to
see
see
how
how
much
much
background
background
noise
noise
there
there
is.
is. I think I should play some like
Okay, so this is a test to record the audio and see the number of background audios. Okay, so this is a test to record the audio and see the number of background audios. So let me now try to record the audio so that I can clearly see the difference between the audio and the background. So let me now try to record the audio so that I can clearly see the difference between the audio and the background. Okay, so this is the audio that I'm recording, and this is the background noise in the background. Let me see if I can basically distinguish them. We'll start with recording our audio and adding a background noise like this so that we can see the difference between the final output. Okay. We'll start by recording audio and adding some background noise. And I will keep talking so that I can see the difference. And we'll start by recording audio and adding some background noise. And I will keep talking so that I can see the difference and close this and then side, I'm able in the background. But I'm continuously speaking, so it should not just take that background noise as an effect. But I'm just going to close that background noise and then I'm going to stop recording.
Hey everyone, today I'm gonna show you how you can fix your audio in one click using AI. All you need to do is head over to Veed and upload your video. When we listen, you can hear the loud noises in the background.
It's a beautiful day, and today I'm gonna show you around in London.
Sounds pretty bad. To fix it, click on the video, find Magic Tools, and click on Clean Audio. And in seconds, AI will turn your audio from this...
I'm actually next to Tower Bridge. It's a beautiful day,
to this.
and today I'm gonna show you around in London. I'm very excited.
And that's it. So fix your audio through the link below, and thank you for watching.
Active noise cancellation is a fascinating hearing. Headphones such as these are able to eliminate or destroy unwanted noise that's produced by the external environment, while simultaneously playing the desired music or audio that's sent from your smartphone. In a nutshell, these types of headphones do this by using a microphone to measure the unwanted noise produced by the environment, and then calculating an anti-sound wave. This anti-sound wave is added to the waveform of your music or audio, and when the combined waveform is played through the headphone speaker, the external noise is eliminated or cancelled out, and just the desired audio remains. That's the basic principle, but there's a lot of intricate engineering that underpins active noise cancellation. In order to better understand the engineering, it's easier to visualize sound waves not as these sinusoidal patterns, but rather as a set of traveling high-pressure zones, known as compressions, and low-pressure zones, known as rarefactions. Let's say you live or work next to a highway. All the cars and trucks that zoom by generate a sound with a waveform such as this, which is really just a sequence of traveling high-pressure and low-pressure zones. These compressions and rarefactions move through the air, and when they hit your eardrum, you hear the sounds of the highway. In order to produce an anti-sound wave for the highway's noise, a sound wave must be generated that's equal and opposite. By that, we mean that for every high-pressure zone from the noise, a low-pressure zone needs to be generated, and for every low-pressure zone from the noise, and when these low-pressure zones and high-pressure zones meet, or vice versa, they average out in that area, thereby eliminating the sounds from the highway. There are a few engineering challenges with this solution. First, the headphones or earbuds themselves provide some passive noise insulation, and therefore we need two microphones. One microphone is used on the outside to measure the noise itself, and the second microphone is used on the inside of the headphones to measure the percentage of noise that's getting through the sound insulating properties of the headphones and into your ear. The second challenge is that it's rather difficult to perfectly time the anti-sound wave with the external noise. The noise from the highway has hundreds of compressions and rarefactions every single second. So, if the anti-sound wave is off by a few milliseconds, then the noise cancellation won't work properly. Therefore, a high-powered digital processor is used to measure and calculate the perfect anti-sound wave, while simultaneously, the interior microphone is monitoring whether the active noise cancellation is in fact working properly. Note that active noise cancellation is more effective for low-frequency, repetitive noises because they have only a couple hundred peaks and troughs, or wavelengths, every second. But high-frequency noises have thousands of wavelengths per second. If there's even the smallest inaccuracy in timing the anti-sound wave with the high-frequency noise, the resulting combination between the anti-sound wave and the high-frequency noise will be ineffective. The third challenge, managed by the processor and circuitry, is that the anti-sound waveform needs to be combined with the audio waveform that's sent from your smartphone. The audio plus the anti-sound acts just like different instruments in a song, and they combine to make a new sound which is played through the single speaker. When the combined audio plus anti-sound waveform and the noise from the environment mix, the anti-sound component of the combined waveform and the noise from the environment cancel out, and we're left hearing just the desired audio. We made a separate episode that goes over the different components of these headphones, and we're working on future episodes that will cover other feats of engineering such as Bluetooth communications, the antenna, and the microelectrical mechanical system microphones. This video was made possible by our sponsor, Peace with Compide Peace. One of these
Okay, I would like to record my audio and see if the background noise is actually helping or interrupting the source, and I can maybe remove that noise. Okay, I would like to record my audio and see if the background noise is actually helping or interrupting the source, and I can maybe remove that noise. The source, and I can maybe remove that. I can maybe remove that noise. Okay, I would like to. Okay, I would like my audio and see if the background noise is actually helping or interrupting the source, and I can maybe remove that noise.
Disgusting. Just kidding.
But hey, Nick Cage beating up.
Disgusting. Just kidding.
I mean, come on. It should supposed
That
to be a
was
10 out of 10
fantastic.
movie.
That
of the
was that was the moment that I fell in love with this movie.
It takes its time.
Disgusting. Just kidding.
But hey, Nick Cage beating up this creature in a living room. I mean, come on. It should supposed
That
to be a
was
10 out of
fantastic.
10 movie.
That
of the
was the moment that I fell in love with this movie.
time. The movie takes an hour.
It sure does.
to establish the characters and just
I fell in love with this movie. I fell in love with this movie.
it takes its time. The movie takes an hour.
It sure does.
It takes its time.
With this movie.
It takes its time. The movie takes an
Love with this movie.
It takes its time. The movie takes an hour.
Sure love with this movie.
It takes its time. To establish the character.
The moment that I fell in love with this movie.
It takes its time. The movie takes an hour.
It sure does.
To establish the characters and just to set it out. And I don't know, it's have this weird
Disgusting. Just kidding.
but hey, the movie takes an hour.
Disgusting. Just kidding.
But hey, Nick Cage beating up this creature in a living room